student working at a college call center. The center pays out every day and offers two different types of payment options at the beginning of your shift. Payment option 1 is t plus 2 squared, and payment option 1 is t plus 2 squared. Payment option 2 is 8t plus 36. In both cases, t is the number of hours that you work each day. Most you can work in is 10 hours per day. All right. So they want you to first sketch the two graphs. To do that, probably a good idea to figure out what's going on at the kind of the two endpoints here. So t and g of t, e and f of t. So what I mean by that is like, well, what's happening at 0, and then what's happening at 10, what's happening at 0, and what's happening at 10. Basically, like worst case, best case scenario. All right. So in the case of the g of t, the line, if you work 0 hours, you actually get paid 36, which sounds pretty good actually. Although I don't think the problem is probably not meant to be defined there. If you work 10 hours, you get $8 per hour times 10, 80 plus the 36, $116 total. After taxes, that may not be very good. In the other scenario here, you get, if you work 0 hours, you're putting 0 in for t plus 2. So that's 0 plus 2 squared. And that is 4, which isn't as much as 36. So you can see you're going to start lower here. But if you work 10 hours, 10 plus 2 squared, let me put the 10 there, is 12 squared, 144. So at some point, this one on the right overtakes this one on the left. So the question is always like, how accurate does your graph, need to be? And I don't know the answer to that. I can just sort of tell you that, well, in one case, you're getting a pretty good starting rate. We'll just call that 36. That's a little low, a little too high. It's sort of steadily rising. And then the other one, you're starting much lower, and you're eventually going to have more.
Okay.
So g of t is this one, f of t is the other. You do not want to draw lines because it says the most you can work is 10 hours. It should also say you can't work negative hours or say, you have to work at least, you have to sort of start to get paid. But that's that's everything for part A. Kind of a lot there, but that is part A.
So you don't really like add any numbers in the y-axis?
You could, I'm just sort of saying, well, that's about 4. That's about 36. They're not to scale. It depends what your instructor wants. So you should do what they want. I mean, if I were in the classroom, I would tell you graphing, we're going to go out to a computer and graph because it's a lot easier, rough sketch, but you know what they want. Maybe they want you to label these points. They really should want to know the intersection point, which maybe we'll get to. But you could, for example, fill in, other places along here if you wanted. All right. Okay, if we move on to part B.
Yeah.
Right. State the domain and range. Kind of already talked about that, but the domain represents the number of hours that you work. And I don't really think you can work less than, you have to work at least 0 hours. So I think it's 0 less than t less than or equal to 10. So I would actually call it an open circle here at the beginning, because you can't work 0 hours and expect you to just get paid $44. It's a pretty good deal.
Yeah.
It's 36, but that's. Are you guys using a set builder notation or interval notation?
I think the first one.
So this is set builder.
Yeah.
That's fine. Just to make sure. So it's got a little preamble to it. T such that t is an element of the real numbers, comma, then this stuff, little curly braces to make it look nice and tidy. And there you have it.
Okay.
All right. The range is the y values. It's like, what is the smallest y value of f of t? And what's the largest y value of f of t? And notice it's referring to f of t, not g of t. F of t starts at 4 and it goes up to 144.
Mm-hmm.
So we would say 4 less than f of t less than or equal to 144. And that's really your y. You can say y such that y is an element of the real numbers. F of t really represents y.
Okay.
Something like that.
Okay, got it.
Okay, so part C is where actually as a person deciding between these is where the intersection of the two occurs, is what you're looking for. For what range of hours would you want to select f of t and g of t as your payment options? And going back to the graph, like g of t is better up until this point here, wherever that is.
Mm-hmm.
And then f of t is better. So it's something like g of t is better from 0 to a certain number of hours. F of t is better for t greater than a certain number of hours. So to determine that point, you have to figure out where does f of t equal g of t? Where do they intersect? So this is where t plus 2 squared equals 8t plus 36. Now there's a couple of ways to solve this. Do you think you would solve this by hand, graphing? What would you most likely do?
By hand.
By hand?
Just
Okay.
yeah.
So we have to expand this on the left. That's t plus 2 times t plus 2. So you have to FOIL that. Could you FOIL that for us, please?
Yes. Would it be 2t to the second power plus 4t plus 4?
Good. Equals 8t plus 36. So now you move everything to one side. So I'm going to subtract both sides by 8t. Subtract both sides by 36. Notice I put them under the thing that they combine with, the like term. So it's minus 4t minus 32 equals 0.
Mm-hmm.
Now you have to be able to factor this on the left. Factoring, you're looking for two numbers that multiply to minus 32, but then add to minus 4. What would that become?
Is it to negative 32 multiplied to
Yeah,
negative
sorry.
30?
Yeah, sorry about that. Yes, it is negative 32. Adds to negative 4.
Negative 4, negative 8.
So they can't both be negative because
Oh,
that would be a positive 32. But these are the right
oh
numbers.
no,
Just got to get
negative 8 and 4.
yeah, t minus 8, t plus 4, like that. Okay,
Okay.
so this means that t minus 8 equals 0, and then t plus 4 equals 0. So t equals 8, and t equals negative 4. So even though these are both solutions, you have to decide if they're both reasonable, meaning, like, are they in the domain?
Uh-huh. The negative 4 isn't.
It is not. So we would exclude that. And a great way to show excluding it is to cross it out. So we know that now that 8 is where these intersect.
Okay.
So basically, we have the answer to this question because we know that g of t, the straight line, g of t is better. I'll just grab this one more time. That's the summary of this. G of t is better, meaning you make more money from 0 less than or equal 0 less than t less than or equal to 8 And then f of t is better from 8 less than t less than or equal to 10.
Okay.
Any questions on that before we proceed to part D?
No.
Okay. All right, part D says, well, what's the difference in pay between the two options after working 5 hours? That means finding g of 5, f of 5, and subtracting the difference. So g of 5 is 8 times 5 plus 36. F of 5 is 5 plus 2 squared. Could you go ahead and calculate each of those for us, please?
The first one is 76.
Okay.
And then the second one's 49.
Okay. So the difference 76 minus 49. There you have it. Go ahead and subtract those and you get $27.
Okay.
All right. So try to look through that problem again and just see if there's anything that you don't think you could do on your own. Doesn't seem overly difficult individual steps, but of course, putting it all together is the challenge.
Okay.
All right, where should we go from here?
Maybe wait. The one above that, the piecewise.
Sounds good. All right, so the picture's a little cramped here. In the future, try to avoid compressing them when you send them over. Just doesn't help the visibility. But it's good enough. It's not too grainy here. All right, so this is interesting. Why? Okay, so the instructor's, I guess, helping here by sort of saying, fill in this table from the piecewise graph. You have to know which of the three to use. It's important to sort of.
Oh, yeah.
But the thing is, unfortunately, you actually need, like at 0, you actually want both values. So I want to do this. So I wouldn't do it this way, but if you think this is the way it's going to appear on your test, we will do it this way.
Okay.
So we'll just go with this. So you look at the first value, -2, and is that between -3 and 0? Is what you ask yourself?
Yeah.
It is. So you have to use minus x squared. So it's minus -2 squared, which ends up being -4.
Okay.
All right, and then same thing for -1, -1 squared. All right, and then 0 is also -0 squared, or just 0. The thing is, though, and I guess I can color code this here, is this first one is these first 3 points right here. And normally I would tell you to graph it as you go. I wouldn't wait to graph it. Because I think sometimes it's unclear. It's like, well, you almost lose track of what it is. So I'd like to do that with you here. Let me snip this in. So from -3 to 0, it's some sort of quadratic. And you probably remember it opens down when it's negative like that. So the graph here, we've got a point at 0, 0, graph that. -1, -1, and then -2, -4. So try to get this to scale here, something like that. Now you got to be careful. It doesn't go down forever. And in fact, it actually stops at -3. So we actually need one more point, but we don't have that. So I don't know. I don't really know why your instructor's doing it this way, but you almost want to show that it stops there at -9.
Okay.
All right, now the next point here, 1 and 2, they go along with this middle one. So when the function just is a number, it means just 1, just the value. So this
Cool.
middle one here is a horizontal line.
Okay.
Now it's also defined at 0. That's why I almost want to add, we almost want to, it's not defined at 0, but you go all the way up to 0. So if you remember what we did one time, is I said, put the output there and just make a note that it's an open circle.
Mm-hmm.
So you really have 3 points here. You have 1 right there, and these are filled in though, and so it's kind of a line like that.
Okay.
Any questions on that so far?
No.
Okay. All right, so now we go to the third one. Third one is the bottom one here. It's good for when x is greater than 2. So again, you kind of have this issue where you need to, like, you do need to evaluate it too. And just make a note that it's an open circle there. So at 2, you're putting 2 into this third function, part of the function there, piece. -2 times 2 is -4 plus 5 is 1. It's not always the same. That's one reason why it's good to do. And then you put 3 in, -2 times 3 plus 5 is -1. You put 5 in, 4 in, -2 times 4 plus 5 is 2. And then finally for 5, -2 times 5 plus 5 is, sorry, this is really bad. It's not 2. It's -3. And then this one here is a -5. So we
Okay.
have to graph those points. So we got 3, 4, and 5. So 3, -1 is about there. 4, -3 is about there. 5, -5 is about there. This one, and it does connect up with that. So it does go down forever, because if you look at the domain, it goes to the right forever.
Okay.
Forever. So just do your best here when you're graphing these. We made 3 tables when we did this together one time. I find that to be a better approach, but you may not have that option. Okay, so now we have the graph. Now we can answer some of the other questions. All right, so we'll start with the domain and the range. Okay, so the domain is the inputs, and you actually get that from the piecewise part. You look at what the leftmost piece is, and then you go to the right, and then you look for, like, well, is there an overlap? There is 0 and 0 overlap. Then you get to the next overlap, and there is the 2. So it starts at -3, but it goes to the right forever.
Okay.
The way that would look is x greater than -3. And you need this other stuff, x such that x is an element of the real numbers, comma, something like that.
Okay. Would it not be stopping at 2 though? Because it's
It does stop at 2, but then it goes beyond that on this one right here.
okay.
Like how far right does this go? I know it's not drawn well, but you see it's going down and to the right forever.
Yeah.
So right forever means forever, no stop.
Okay. Okay.
All right, the range is the y values. So you have to think, well, how far down does this thing go? Goes down forever. Okay, and then what's the maximum y value? What are the y values here in blue?
0, 1, and 2.
Just the y values. What are the y values there?
Oh,
So If you go back to the table, what are the biggest y values?
It's just one.
Just one. Yep. So the range is all the numbers less than or equal to 1.
Okay.
And then you
And
need
do
that
you,
question.
oh no, I was gonna ask about that.
Yeah, you have to include all that if it's set builder, which, I don't know, but let's just presume it is.
Okay. Yeah.
Okay, so we've got that. Now the end behavior is the next thing. And we do need the graph here. I almost want to graph it better, but I'm going to keep grabbing. Let's grab a snip of it. Okay, so the middle, sorry, end behavior, that's number 3. So this is at the extreme end. So you want to see something like as x goes to infinity, meaning as you reverse the curve to the right forever, what happens to the y value? Like how far down does
Oh,
it go?
is it going to negative infinity?
It does. You would say f of x goes to negative infinity. Now, normally you go the other direction as well, but we don't go to the left forever. In fact, the leftmost x value is -3. So you would say as x approaches -3, what does the y value approach? So that's this endpoint over here on the left. Like as x approaches -3, the y value there is -9.
Okay. Wait, how'd you get -9 and -3 again?
Okay, so if you go back to the original says it's good up to -3, but not including it.
Okay.
And so I just put -3 back into this to get -9.
Oh, okay. Got it.
Okay. So without that point, you could easily look to the wrong place, but it does stop here. It stops there. So that's why it's as x goes to -3, because you are stopping right there. Okay, and then f of x goes to -9. Now we got to do the same thing for the middle behavior, which is really weird. All right, so basically what happens as x approaches 0? Did you guys use this notation from the left?
Yeah.
As x approaches 0 from the right. I'm asking because I don't know, and I don't want to give you something that you haven't seen, because then it could look weird if you put it on the test.
No, he has used it.
Okay, so this first notation here means from the left. I'll write that down here, from the left. So you figure out where 0 is on the graph. There's my cursor, and you approach it from the left. What's the y value there from the left?
Oh, it's 0.
0. So you say f of x approaches 0, like that. Then the next one is from the right. So you come from the right. Okay, from the right, from the right, from the right, from the right. And you approach 0, but this time there's nothing there, but you still use the value even though it's not defined there. Because the way limits work is they don't have to actually exist, they just have to be a destination. The destination here is +1,
Okay.
even though it's not defined there. Right, and then the next one is the middle behavior at 2, which has as a better situation here. As you approach 2 from the left, and as you approach 2 from the right, it meets in the same spot. It's like when you and your friend, you're like, hey, let's meet here. You're like, all right, there, I'm there. That's good. That's a good thing.
Okay.
So we use the same notation. You say as x approaches 2 from the left, or as x approaches 2 from the right, f of x approaches 1, f of x approaches 1 or equals 1.
Okay. Yeah, I think I'm good with that.
Okay.
Could we do the inverse and slash exponents? Or
Is
the
that
exponents
is that
slash
is that number 3? Or I'm sorry, is
yes.
that problem 1 with
Yes.
the logarithms? Okay. So just a little hard to read, that's all. I dislike how the phones want to compress the pictures, but that's what they do. All right, so they're giving you a function here, log base 2 of this thing, 1/2 x plus 8 minus 1. It says evaluate the following. Okay. So we're gonna put these values in for x. So this means take -4 and put it in for x. Log base 2, 1/2 minus 4 plus 8 minus 1, like that.
Okay.
So to do this, we first take -4 and add it to 8, positive 4. Then take half of it, that's 2. So this is log base 2 of 2, and then -1. The -1's kind of off to the side.
So
Is
this
that
is
okay? Sorry, I didn't catch that.
is the answer just 0?
It is, because log base b of b is 1. This part is 1 from last night. 1 minus 1 is 0. Yes.
Okay. Okay, that makes sense. I think we can move on from this because I know how to do that.
Okay. Where would you like us to go next?
Whichever, the one that says solve the location where the vertical asymptote of the
Okay.
function.
We will need the other points to graph it, the other
Oh,
evaluations,
okay.
but you can either give those to me or I can just sort of estimate where they are. But yeah, part B here.
Okay, let
So
me get them done.
what I can't tell is the third one 8, f of 8?
The third one? Yeah, it is.
Okay. Okay.
Oh, wait. Okay. So you first add a plus 0,
Yes.
and then divide that by 2.
Yes.
And then the log of 2 would be 1.
It's 8, half of 8 is 4. This is log base 2 of 4 minus 1. And so that's a little bit different.
So would it like come out to 2 for the
It
log?
is. Yes, it becomes 2 minus 1.
Okay.
If you need explanation on that, I can provide that, but this is the correct answer. All right, good on that. So why don't you do the same thing for f of 8?
Oh, 2.
2. Good. Okay, so we need those points to graph it. Now, before you graph, though, you have to solve the location where the vertical asymptote of the function. So the vertical asymptote in a logarithm is where the part that's inside the logarithm is equal to 0. You set the inside part equal to 0 and then solve for x. So to do this, you would first clear out the fraction by multiplying both sides by 2. And that leaves x plus 8 equal to 0. So x equals minus 8. Okay, and you really want to graph as you go. Can't emphasize that enough. You don't wait till the end. It's easy to leave out stuff. So when you're graphing this thing now, you go over to minus 8. And you have a vertical asymptote there. So typically it starts down low and it comes up, crosses the x-axis somewhere, and then the y-axis somewhere. Okay. Now, when it's just to sketch a graph in part C, that's where we use the points that you just found. So we use the fact that at -4, it's 0. And at 0, you said that it is 1. And then at 8, it's 2. So that's enough to sort of create a nice, smooth graph that looks like that.
Okay.
Now, just to be clear, this goes up and to the right forever.
Okay.
All right, now you've sketched the vertical asymptote. You've labeled the x-intercept right here, -4, 0. 0, 1 is the vertical intercept or the y-intercept. It says to label the intercepts. You've done that. Okay. Any questions on that before we proceed to part D?
No.
Okay. So algebraically find the inverse of f of x. So I'll rewrite f of x, which is y equals log base 2, 1/2 x plus 8 minus 1. All right, to find the inverse, there is a recipe. I don't know if you like to cook or bake, but there's a recipe, set of steps. You switch x and y. Okay, switch x and y. Next step is to solve for y, and this is where the bulk of the work is, especially if your algebra skills are not very solid, because you may not know how to get there. But to do this, first we'll move this -1 over, so you're going to add 1 to both sides. So you have x plus 1 equals log base 2, 1/2 y plus 8. All right, so you don't need to know the right words, but do you know what to write to undo log base 2?
Don't you put like the base under it to cancel it out? Right?
Exactly, yeah, exactly. And the wording there is not really important. It's important that you know that as a result of this, you get on the left 2 to the x plus 1 power. On the right, you just get the stuff that's inside parentheses.
Okay.
All right, so the next step here is to solve for y. You have to undo this 1/2 by multiplying both sides by 2. All right, and so that clears out on the right. On the left, there is a way to simplify this. There's really a 2 to the power of 1 there. And when the bases are the same, you end up adding the exponents. So it'd be 1 plus x plus 1 or x plus 2.
Yeah.
And then you subtract 8 from both sides. So that doesn't combine with anything. It's just kind of off to the side. 2 to the x plus 2 minus 8, like that. And it's really better to have y on the left. So I'm going to move it there now.
Okay, got it.
Last step, this is actually the step 3, is to actually write the inverse notation. Doesn't seem like a big deal, but notation is important in math.
Okay.
All right, any questions on that before we graph it here, part E?
No.
Okay, so in part E where it says to graph it, option 1 is to make a table. Option 2 is to use the symmetry of y equals x. At the very beginning of when you learned about how to graph or inverses, you talked up, I'm sure at some point your instructor said like, yeah, it's a mirror image over a line y equals x. Does
Mm-hmm.
that sound at all familiar?
Yeah.
So what that means is every place you basically mirror image. And
So
um,
could you just make a table switching the y and x values?
you can also do that as well.
Okay.
So it kind of depends, you know, what do you like doing? You just gotta be careful that you don't because there is a it's got to have the right look here as well.
So would the other table be 1, 0, 0, -4, and 2 and 8?
So I've approximated those points on here.
Okay.
It's much harder to draw this than it is to just do a
Mm-hmm.
table. So just make it look reasonable. I mean, what I've got passes the eyeball test.
Wait, where's the negative? Where's the 8?
Here somewhere, we'll say.
Because you go 2 to the right and then you go down 8.
It's positive 8 here.
But for
8.
the
The inverse is just the switching of them, not the signs. You just switch the numbers.
oh, that's what I meant, like the 8, like it would be 2 to the right and then down 8.
But this point here is 8, 2, 8 comma 2. And you just switch the order of the numbers. There's no negation.
Yeah, that's what I got. I just switched the numbers. Like I switched it to 2 and 8 for the inverse.
That's right. So it's right 2 and up 8, not down.
It has to be up 8. Oh yeah, you're right. Never.
It's okay.
Okay.
It's finals time. We're all a little tired. Just make it look reasonable. you know, the teachers want easy. They want easy. They don't want to like hem and haw over what it could be. They just want to know that it works. Looks
Okay.
okay. All right. So we can move on to F if you would like.
Yeah.
All right. All right. So new question here. We don't. It's really not part F. It's like a new question altogether. It says algebraically verify that h of x and f of x are inverses of one another if h of x equals 3 parentheses x minus 4 squared minus 1 and j of x equals 1/3 root 1/3 x plus 1 plus 4 through composition. So that's the important part here. You have to do two things. You have to find h of j of x, and this should equal x, and then j of h of x, this should also equal x. If they both equal x, they are inverses.
Okay.
All right, so in the first one here, will be the first one, you're taking all of this that I've circled and putting it in for x. Right, so
Okay.
it's very messy, but it's not impossible. So it's the adjust x, so you're leaving everything else. So it's the square root 1/3 parentheses x plus 1 plus 4 minus 4 squared minus 1.
Mm-hmm.
So these plus 4 minus 4 obviously goes away. The square undoes the square root. So we should show a little work here. 3 times 1/3 x plus 1 minus 1. 3 times 1/3 is 1. That leaves x plus 1 minus 1. And so that does work. That's only half of what you need.
Mm-hmm. So you would have to do the same thing to the other one.
Unfortunately, you have to do the same thing in the other one. And it's these aren't, I mean, they're not terrible. They've seen worse, but yeah, you can take all of this and put it in for x. So why don't you try that here real quick? See if and you got to show a few steps. You can't just say, yep, it equals x. They want to see a little bit of work integrating this thing.
Okay. Would the inside so far be 1/3 parentheses 3 parentheses x minus 4 parentheses squared minus 1 plus 1 parentheses plus 4?
The plus 4 is off to the side
Okay.
with the root on the outside. Yeah.
Would the -1 and +1 automatically cancel?
Yes. Yes. And then you will end up multiplying the 1/3 times 3 before you square.
Time? Oh. Okay, so that's just 1.
Yep. So it ends up being x minus 4 squared square root.
And what do you do once you're at 1 and
When
then x
you keep saying
minus?
you said 1 a couple of times. You mean 1/3 times 3?
Yeah.
Just don't write it anymore. It's just gone. It's just x minus 4 squared.
Oh,
I
okay.
mean, you can put a 1 there if you want, but multiplying by 1 doesn't really do much.
Okay. And so what do you just
the square root undoes the square. So the x squared square rooted is x, kind of. And then x, the square root of x squared is also x. So they undo each other. They're inverses of one another.
So it's x minus 4.
The square root undoes the square. It's gone. Just poof. Kind of like a magic trick.
Oh, okay. Okay, got it.
Fantastic. So when they both equal x, and they tell you have to do it through composition, because the other way to do it is like what we did in the previous problem here, where you switch x and y and then solve for y. That's one way to do it, but they're telling you like you must use function compositions. That's another thing on the finals, is always do it the way they want. Don't try to assume that you can do it your way. Give them what they want there. So all right, we're pretty much out of time for today. I know there's a little bit more here to get to. Happy to do that with you later on, if needed. There's also some stuff from yesterday. I can also make up problems like the ones that are on here, if that would help. So I'll leave that
Okay.
to your decision. Um,